In this lesson, we are going to look at all the necessary substitutions that you have to do or you should know when doing x equal to tangent of theta on 2 substitution. Now, if we consider x equal to, or if we consider the substitution x equal to tangent of theta on 2, let us consider this right-angled triangle with the angle here equal to theta on 2. Then, tangent gives us opposite divided by adjacent. So we take here x divided by 1. Now, what will be the hypotenuse? The hypotenuse is x squared plus 1 squared. And we put square root around it. So the hypotenuse will be x squared plus 1 under the square root. Now, if we take cosine of theta on 2, we are going to get adjacent divided by hypotenuse, 1 divided by the square root of x squared plus 1. If we square both sides, you're going to get cosine squared of theta on 2 equals 1 squared is 1. And if we square this, you get x squared plus 1. Now, if I take sine of the angle that is theta on 2, I get opposite divided by hypotenuse. That is x divided by square root of x squared plus 1. If I square both sides, I'm going to get sine squared of theta on 2 equals x squared divided by, if I square this, I get x squared plus 1. Now, let's see this simple identity. Cosine of theta equals cosine of theta plus, theta on 2 plus theta on 2. Now, this expands to give cosine squared of theta on 2 plus minus sine squared of theta on 2. Now, cosine squared of theta on 2 is 1 on x squared plus 1. Yeah, 1 on x squared plus 1. And sine squared of theta on 2 is x squared on x squared plus 1. So if I simplify this, I get cosine of theta equals 1 minus x squared divided by 1 plus x squared, or x squared plus 1. That is very, very simple as that. Now, if I take sine theta, that gives sine theta on 2 plus theta on 2. So this expands to give 2 times sine theta on 2 times cosine of theta on 2. Wow. Now, if I divide this by cosine of theta on 2 and then multiply it by cosine of theta on 2, I can get a very nice expression. Sine theta on 2 divided by cosine of theta on 2 gives tangent of theta on 2. Yes, that is very, very simple as that. And if I multiply cosine of theta on 2 to cosine of theta on 2, I get cosine squared of theta on 2. Now, this gives me 2 times x, since tangent of theta on 2 is x. And here, cosine squared of theta on 2 is 1 divided by 1 plus x squared. So this simplifies to give 2x divided by 1 plus x squared, or x squared plus 1, as sine theta. Wow. So this is how we prove these formulas. So learn how to prove them and then also how to use them. They are very, very necessary when you're doing, if you differentiate x, you get the x. To differentiate tangent of theta on 2, first differentiate theta on 2 to get half. Then we differentiate the whole of tangent of theta on 2 to get secant squared of theta on 2, the theta. Wow. I hope you enjoyed the lesson. Please kindly like, share, subscribe, and follow me for us to board the mathematics community. We multiply 2 by 2 to get 2 times the x equals secant squared of theta on 2, the theta. Now let us find an expression for secant squared of theta on 2. This expression is simply 1 plus tangent square of theta on 2. And tangent square of theta on 2 is the same as x, as we have the... Oh, sorry, I didn't bring the 2. Wow, I nearly forgot. Let's see how we do it. That's very, very great. It's great to remember. So the derivative of x equals tangent of theta on 2 gives us what we have here. Now, we are going to replace the whole of this by squaring here and then squaring here. We just get tangent square of theta on 2 as x squared. So we write 1 plus x squared d theta and then divide both sides by 1 plus x squared. So this gives 2dx divided by 1 plus x squared equals d theta. So these are the necessary substitutions that you have to do, or you have to remember when you are doing tangent of theta on 2 substitution. Please follow, like, share, and comment.